All right, day 59. The 3-minute. This is 6.6a, the first of 2 days that we're going to be talking about exponential equations. Brand new topic, but not too difficult, I don't think. You'll see. It all starts with this idea of knowing your powers. You know, powers of 3 and powers of 2 and so on. Knowing your exponent rule. So the goal, evaluate expressions involving exponents. So here we just want to fill in the blanks. So we've got 81, and that's 3 to the exponent something. And so the question is what goes in this blank? Well, you can use guess and check in your calculator, or you just sort of start multiplying up by 3. 3 times 3 is 9, times 3 is 27, times 3, well, 27 times 3 is pretty darn close to 81, isn't it? So that's 4. The next one, well, we end up with a fraction, right? It's kind of like 2 to the exponent 1 in the bottom. Well, what is, when we end up with a fraction, that means a negative exponent, right? So this is negative 1. And again, to check that, negative exponent is 1 over 2 with the positive power, right? And we don't get the negative exponents mixed up with fractional exponents, right? We saw fractional exponents, this sort of thing, 4/3, that's when it means roots, right? Whatever that would be, we don't know. We can't do that without a calculator. But negative exponents means fractions. Well, negative exponents means fractions. Fractional exponents mean roots. How do I end up with 1? 6 to the exponent something equals 1. Well, that was one of our rules, right? A to the exponent 0 always equals 1. So, if this is a 6, 6 to the exponent 0 is equal to 1. So 6 to the exponent 0 is 1. This one, 125 is 5 to the exponent something. Again, we kind of just got to know some of these. 5 times 5 is 25. Times another 5 is 125. This is 3. Right? So what is it if it's on the bottom? Well, this is the same as 1 over 5 to the exponent 3. So if it's a fraction in the bottom, this is 5 to the exponent minus 3. Right? And again, going normal way for us, let's check that. Negative exponent means flip the base, positive exponent, and then there's the 125 just like we expected. That's the check. Okay, so this one, what is it? Well, 49 is just 7 squared. I think of that in my head, and so since it's on the bottom, this is minus 2, isn't it? Easy, this stuff. And we'll see this thought, these thoughts, this train of thinking will allow us to solve equations involving exponents. Solve equations where the exponent is unknown. Notice this is brand new for us. We've never sort of done this, is try and find the answer to questions where the unknown was in the exponent. But if it looks like this is pretty easy, right? I got 3 to 3 to the exponent x equals 3 to the exponent 7. Well, the left side and the right side are equal. The bases are the same. So just compare. The exponents must be the same. Done. It has to be. It's the only spot left over for something. X has to be 7. And thinking of this as an easy question, well, how do we solve this? We need this to be a power of 3. And that's the whole strategy, is to write both of these as a power with the same base. So this becomes 3 to the exponent x equals 3 to the exponent something. Now, does this sound familiar? What's 243? Well, I kind of got to do guess and check, or I gotta do a bit of work, calculator work or whatever. 3 times 3 is 9, 27, 81, 243, that's 5. So I'd see, therefore, x equals 5. And so in this one, it's not a base 3, it's base 4. So what I'd like to do, if I can get this side as 4 to the exponent something, I'll be moving in the right direction. And I'm just writing this this side down, but 16 is 4 to the exponent what? Well, it's 4 squared, isn't it? So since the bases are the same, that means the exponents are the same. Now, notice what happens on this one. I'm not done yet. I got a little more work to do here to find x. Well, this is just a little tiny grade 9 equation. I get x equals 5. That's done. I could always put that back in to check. It would work out. Is that it for this slide? Next slide. Next slide, please. They get harder, right? These look terribly hard compared to when we started, right? We started with this question, but that's what learning's about, right? Here we got a power of 2, and we know 32 is 2 to the exponent something. So what I'm going to do is I'm going to think. We're going to write down the exponent here, but I'm going to think this is 2 to the exponent something. 32 is 2 to the exponent something. Well, what is it? It's 2 to the exponent, well, guess and check on your calculator or count up. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's 2 to the exponent 5. So 32 is 2 to the exponent 5. Well, what's going on here? This doesn't look normal, but at least I have the left side and the right side both as powers of 2. But I'm kind of worried about this. Like, what's going on here? Well, this is just powers on powers. This is just, exponents on exponents. To solve that question, if it was numbers, well, that's a 4. I just multiply, right? I just multiply these. So I just multiply these. Right? Just multiply. And so now I can say, therefore, since the two powers are the same and the bases are the same, the exponents must be the same. And now I have a slightly more difficult grade 9 problem, right? Expand the brackets. Get all the x's on the same side. Collect like terms there. There, the 5x is gone. I'm left with minus 5. Here, I'm left with minus 2x. I'm copying down the minus 1 for now. Adding 1 to both sides is the next step. I'm thinking about going down the page here. Equals net minus 4. Finally, the last step, dividing by minus 2. X equals 2. And if I went back and put that into the original equation, I'd see that the left side is equal to the right side. This one looks more difficult. I got a fraction on this side. I got 100 on this side. Hard to see what my common base is going to be on the left side and the right side. Well, let's think about this for a second. I'd like this thing to be the same thing. Not 2. It can't be 2. Well, maybe 10, right? 100 is 10 squared. Right? 100 is 10 squared. What about 1 over 10? Fractions are negative exponents, 10 to the exponent minus 1. And now I've got this sort of thing on both sides. I got a step multiply exponents. Minus 1 times 2x. And now I can compare the exponents. Right? The two sides are the same, and I got the same bases, so then, therefore, the exponents are the same, and I can start doing grade 9 equation action on it. How do I solve this? Well, I want to get all the x's on one side, and I'll add 2 x's. I'm going to try and avoid the negatives here. Notice on this side, when I add 2x to both sides, this is 0. This is 4x, and I'm copying down the minus 6. This is kind of weird having a 0 there, but that's not bad. Add 6 to both sides now. And then I divide both sides by 4, finally. X equals 6/4, which I could get a decimal, but I'm going to put that into lowest terms. Divide top and bottom by 2. That fraction in lowest terms is 3/2, or 1.5. Done. That's as hard as they get, that one right there. That last one, as hard as these ones get. practice on the homework. Have funsies.